this second video, I'll explain you some examples of how to solve inequalities. Before will try to translate into English talk about some statement, but this one, before we go to the solution, we solve it. So this is the first example, example 5. I will give you until example 11 example, okay? So this is the first one, and how to know what is the solution set for this inequality. Again, if it is not stated, we can assume it is real number, but this one, it's already been stated that the domain is real number. So let's go to solve this inequality. The objective for solving inequality is to isolate the x. So let's isolate the x. How? The first one is using addition property of equality. So I want to get rid of 6 here on the left member, and that's why I want to subtract both members by 6. Okay, so in the end I will do the arithmetic. I will have 3x is greater than and equal to -4, and then I will try to isolate x by get rid of 3. How? By multiplying it with its multiplicative inverse. So let's use the multiplication property of equality. So when I try to multiply something on the left, I will try to multiply the same thing to the right member. But again, keep in mind, as long as it is positive, okay, the multiplier is positive, you don't have to switch or flip the sign. You don't have to reverse the sign, so it's safe. So when I did the arithmetic, I will have this is my final statement of inequality. Therefore, I can translate this with the English talk, which is the solutions for x are all real numbers that are greater than and equals to -4/3. Okay, so all real numbers. So how to present this? Yeah, let's just do the number line. I don't like the solution set, so this is the number line that I use, the tick marks and the numbers. Again, it's greater than -4/3 here. So greater than, it means all the numbers on the right side of -4/3, including -4/3 itself. So I will put a closed circle here, and then that's it. So there is other way to make your number line simpler, which is I use this kind of number line. So I just only provide 2 tick marks, and this is the border, so it must be visible, and the 0 here is just to present the direction, so the positive or the 0 is on the right side. Okay, just to make clear. So in the end, you just put the closed circle right on the -4/3, and then you just put the arrowheads to the right. That's how you use the number line for this kind of example. This one, yeah, that is for example 5. For example 6, I'll try to use the same example, the same inequality with the previous one, but I will change the domain. So let's see what is the impact if we change the domain. Before we speak about real numbers, now negative reals only. So as usual, if you want to solve the inequality, we have to isolate the x. Okay, so we will have the same, exactly the same steps, addition property of equality, and then we just subtract both members by 6, and then do the arithmetic, and we'll have this. Okay, and then I will get rid 3 by multiplied by its multiplicative inverse. In the end, this is the last statement, right? Just the same like the previous one. But again, if I change it, translate it into English talk, and I combine this statement by its domain, negative reals, it becomes the solutions for x are all negative real numbers that are greater than and equals to -4/3. Okay, so all real numbers, but must be negative. Only negative real numbers. That is the difference. That's why previously we have this as your number line, but this one includes all real numbers that are greater. But since we can only include negative reals, it means 0 cannot be included and all positive reals cannot be included. Therefore, our number line becomes like this. Okay, well, this one I don't shade it. Okay, but just keep in mind that all the solutions, all the solution that you have is between negative 4/3 and 0. All numbers inside or between that will be your solutions. And negative 4/3 is also your solution since we use the closed circle. But 0 itself is not the solution since 0 is not negative real number. Okay, so the open circle must be used. Why? Because the negative real that's really close to 0, for example negative 0, negative 0.00000001, it must be included. So there is no other way to point that except by using open circle. Okay, it means the open circle 0 is not included, but the closest possible negative real to 0 is included. Okay, the next example, I'm still using the same inequality, but I will change again the domain. Okay, before we use real numbers, negative reals, and now how about if it is negative integers? Okay, so let's solve this inequality first. And we will have the same, exactly the same steps. Okay, solved by isolating x. And in the end, we have this statement. So when I combine this statement with the domain, the English talk becomes the solutions for x are all negative integers that are greater than and equal to negative 4/3. All negative integers. Well, for this part, only for this specific situation, we can actually put it into solution set. Why? Because we only have one solution set, which is negative 1. Try to find other negative integers that are greater than and equals to negative 4/3. None. Only one, which is negative 1. Okay, so we have no 0, not negative 2, it's not. So actually you can be satisfied with this, but if you have to present it on the number line, so we can only use this one. So negative 1, put close circle. There, done. Again, you do not be bothered with this inequality since the number line only shows what is all possible solutions for your inequality. This is example 8. So here it is, the inequality 2 minus 2x less than 6. Okay, let's put the domain now is integers. How if domain is integers? Okay, so let's solve this inequality first by isolating the x. So first I will use the addition property of equality and I will subtract both members by 2. Okay, after that I will do the arithmetic. In the end I will have negative 2x is less than 4. Okay, and then I will get rid of negative 2 here to make x isolated. So I will multiply it by its multiplicative inverse, which is negative 1/2. Okay, so the multiplication property of equality, and you will have this one. Both members are multiplied by negative half. So the impact is, be careful, since you multiply both members by negative, you reverse the sign. Before it is less than, it becomes greater than only by multiplying or dividing by negative numbers. Okay, so that is the key point for example 8. In the end, after you multiply it, it becomes x is greater than negative 2. From here, so we can start to draw the number line, to graph the number line. So before we graph, let's translate it first. Combine this final statement with the domain. It means all the solutions for your x are all integers that are greater than negative 2. All integers only. So it's not real numbers, it's just integers. Okay, so what is the number line? It is like this. Or if I want to go to step by step, this is my tick marks. Okay, since I need to present all integers that are greater than negative 2, this is negative 2. But since negative 2 is not included, it is not, it's just greater than. So let's start from negative 1, right? So let's put the close circle negative 1. What else? Well, it's 0, of course. And then 1, 2, 3, and then so on. Until it continuously go to the right. It means don't forget that you have to thicken the arrowhead to the right. For example, 9, we have 3 members here. This is the difference. We have left, middle, and right. Okay, so if I have to say it, it is inequality that speaks about that 2 minus 2x is between -4 and 6 exclusively. It means -4 and 6 are not included. So how to solve this inequality? First, we put the domain. If it is not stated, let's assume it is real number. And then by solving it, it means we isolate x. We isolate the middle member. Okay, so let's isolate this by using the same things, addition property of equality. So I want to get rid 2 first. Okay, so I will subtract all of it by 2. Okay, so when you try to apply addition property of equality in this kind of inequality, you have to do all the same to the all members. Okay, left, middle, and right. So let's do the arithmetic. In the end, you will have -6 less than -2x less than 4. Okay, so or if I want to speak it in the perspective of -2x is between -6 and 4 exclusively. So next one, let's get rid of -2 by multiply all by -half, right? So since you multiply by negative, again, use reverse the sign. Originally it's less than, it becomes greater than. Don't forget about this. Okay, so let's do the arithmetic. In the end, you have the statement that x is between -2 and 3 exclusively. So if I put it into English talk and combine it with this domain, the solution for x are all real numbers that are greater than -2 and lesser than 3. Okay, or I can put it another way, the solution for x are all real numbers that are between -2 and 3 exclusively. Again, exclusively means it's not included. The -2 and 3 is not included. It's just the border. Okay, so if we are speaking about real numbers, all real numbers that are close, really close to -2 and 3 inside the area will be included. So let's go to the number line. It means if I do the number line, I will use this statement. Okay, Mr. Why is there only 2 tick marks? Well, I want to present you an example of how simple you can have a number line, but the information is already there. Okay, this is the simplest one, but you need to make sure all information that necessary to be presented is there. By seeing this, I can see that all solutions are between -2 and 3 and all real numbers. It means -2, -1.5, -1, 0, 0.1111, all numbers between them is the solution except -2 and 3 itself. So yeah, it speaks the same with the last statement that you have and the domain that it really represents. So this is enough. Examples, we are trying to solve inequality with absolute sign. Yeah, okay, you can see this example here. So this will be the last 2 examples. How about absolute sign? Now, before we solve it, before we isolate x, we need to translate this first, okay? Since absolute means the distance from the origin, it means the 5x minus 3 distance from the origin must be less and equals to 7. Okay, so it means must be between 7 and -7. Okay, let's recall back to the definition of absolute. Before we go further, let's establish the domain, its real number. So let's translate this. Again, this is your translation of absolute. So it's between 7. It means the distance must be from the origin must be 7 units. It means 5x minus 3. It is between 7 and -7 inclusively. Inclusively means it is included, -7 and 7. There are equal signs there. Okay, so from this point, let's just do the same thing like the previous example. I will try to isolate x, in the middle member. So I will use first addition property of equality. I will get rid negative 3 by adding all members by 3. So in the end, I'll do the arithmetic. I will have negative 4 is less than equals to 5x, which 5x is less than and equals to 10. Or from the perspective of 5x, 5x is between negative 4 and 10 inclusively. So the next one is multiplication property of equality. Why? Because I want to get rid 5 here, isolate x. So I will multiply it by its multiplicative inverse, 1/5. Since it is positive, I don't have to reverse the sign. It's still the same. Okay, so in the end, this is my last statement. The last statement, let's just put it into English talk before we go to the number line to make it easier for you. So the solution for x are all real numbers that are greater than negative 4/5 and lesser than or equals to 2. Okay, or if I put it in other kind of way, okay, the solutions for x are all real numbers that are between negative 4/5 and 2 inclusively, because negative 4/5 and 2 are included. So it's because there is a specific borders here, negative 4/5 and 2. So this is your number line. Okay, inclusively means negative 4/5 and 2 are included. So we put close circle, and this one shows that all numbers inside this area will be your solution sets. Yes, it's true because we are speaking about all real numbers. In this last example, we will still use the absolute sign and inequality, and this is your problem, and the domain will be positive integers. So yeah, if we look to the problem itself, the absolute sign again shows the distance. It means the distance of 5 minus 3x from the origin from 0 must be greater than 7 units. It means if I show it on the number line, this is 0, for example, this is 0. So the distance must be greater than 7 units. So it must be here or here. It goes right there or goes left. So all the units, all the numbers, all the values that inside of these both areas will have the distance is greater than 7 from 0, right? So let's translate this into this statement since it's greater than 7. So 5 minus 3x must be greater than 7, or 5 minus 3x must be lesser than negative 7. So I want you to avoid this kind of writing, okay, since this doesn't make sense. It doesn't make that 5 minus 3x is between negative 7 and 7. No. So we will avoid this. This is not between. It is different with the previous one. So yeah, makes sense since it's between negative 7 and 7. Okay, but this one, it is not. Okay, since it is greater than 7 but lesser than negative 7. Therefore, we use this instead. Okay, stop using this for this specific case. We are using this, although it kind of showing the same thing, but I want you to know that we have to use this second statement. So either 5 minus 3x is greater than 7, or 5 minus 3x is lesser than negative 7. Is less than, I mean. So now let's go to isolate x for both cases, this one and this one. So let's just do the same thing, addition property of equality. So I will just subtract both sides by 5. Okay, so yes, you applicate for all. Okay, and then let's do the arithmetic. In the end, for the first case, negative 3x is greater than 2, and negative 3x is less than negative 12. Okay, now let's get rid of negative 3 by multiply it by negative 1/3, right?
since you multiply it by negative, again you reverse the sign for both cases. Okay, in the end, you will do the arithmetic and you will find the last statement, which is x is less than negative 2 over 3 or x is greater than 4. So there are all your solution sets. When we combine with the domain, okay, the English talk speaks about, this one speaks about the solutions for x are all positive integers that are greater than 4 or less than, negative 2/3. Okay, so actually you can know that it doesn't make sense for the second statement, for this one, less than negative 2/3. How can we have a positive integers on this area? So therefore, this won't be included. The domain limit your solution. Although you have a complete solution like this, but since we only can include positive integers, this one cannot be included. I hope that you can understand that. So in the end, let's speak about the number line. So what are all positive integers that are greater than 4? Since this is not the case, so let's start by 5 and then 6, 7 and goes up 5, 6, 7 with close circle and then thicken the right arrows to show that it's showing the same pattern into infinite positive. That's how you solve it for this last example. I hope this is understandable and just do your assignment and practice so you can master this concept well.